Hey everyone, I am Ummehani studying CSE Artificial Intelligence in Sri Venkateshwara College of Engineering. So, today I welcome all of you. I belong to Department of CSE Artificial Intelligence, 3rd SEM. Subject to discuss today here is operating system. Let's move forward. The topic to be discussed here is deadlocks in operating system. Introduction to deadlocks in operating system. Deadlock is a state in which two or more processes are unable to proceed because each is waiting for the other to realize a resource. Deadlocks can occur in multi-programming systems where multiple processes compete for a finite set of resources. Deadlocks can lead to system instability and cause a system to become unresponsive. Necessary conditions for deadlocks. Mutual exclusion. At least one resource must be held in a non shareable mode, meaning only one resource or one process can use it at a time. Hold and wait. A process is holding at least one resource and waiting to acquire additional resources held by other processes. No preemption. Resources cannot be forcefully taken away from a process, they can only be released voluntarily. Resource allocation graph, that's nothing but RAG, is a visual representation of resource allocation and resource request. In a RAG, processes are represented by nodes and resources are represented by edges. If a cycle exists in the RAG, it indicates the possibility of a deadlock. Deadlock prevention. Deadlock prevention aims to eliminate one or more necessary conditions for deadlock occurrence. Strategies for prevention include resource allocation policies, process initiation policies, and deadlock avoidance algorithms. Prevention techniques can be complex and may affect system performance. As we can look into the picture, the differences between deadlock prevention and deadlock avoidance. Deadlock avoidance predicts whether a resource allocation request will lead to the deadlock and decides whether to grant it or not. It uses algorithms to determine a safe state where the system can allocate resources without risking deadlock. Avoidance algorithms may require additional information about the maximum resource needs of each process. As we can look into the picture, that's nothing but an example of resource allocation graph for deadlock avoidance in the safe state. Deadlock detection. Deadlock detection involves periodically examining the resource allocation graph to identify potential deadlocks. Deadlocks algorithms identify the presence of a deadlock and the processes involved. Once a deadlock is detected, appropriate actions can be taken to resolve it. Deadlock recovery. Deadlock recovery involves breaking the deadlock by terminating one or more processes or preempting resources. Recovery methods can include killing processes, resource preemption, and rollback of processes. Recovery should be done carefully to avoid data corruption or system instability. As we can look into the picture, deadlock recovery, process termination terminates a single process and also terminates all process, wherein resources preemption and rollback undergoes in resources. Avoidance, deadlock avoidance versus deadlock detection. What is deadlock avoidance? It's nothing but the deadlock avoidance aims to prevent deadlocks before they occur, while deadlock detection identifies and resolves existing deadlocks. Avoidance requires more system resources and may limit the system's performance, while detection is less resource intensive. Both techniques have their advantages and disadvantages and are used in different scenarios. As we can look here into the picture, deadlock prevention, it's a mechanism to ensure that at least one of the necessary conditions for deadlock can never occur. Wherein, when it comes to deadlock avoidance, this mechanism is to ensure that the system does not enter an unsafe state. As below as follows. Next is best practices for deadlock handling. Design the system to minimize the possibility of deadlock occurrence. Implement deadlock prevention or avoidance techniques based on the system's requirements. Regularly monitor and detect deadlocks to take appropriate actions for recovery. By concluding the topic, deadlocks are a state where processes cannot proceed due to resource conflicts. For necessary conditions, like there are four necessary conditions for deadlocks, such as mutual exclusion, hold and wait, no preemption, and circular wait. Deadlocks can be prevented, avoided, detected, or recovered from using various techniques and algorithms. By concluding, thank you.